Hello students, and welcome to the third lesson of Module 3. In this lesson, we're going to learn how to find the derivative of composite functions. You're going to learn how important this is, and we're going to tie it into the product and the quotient rule that you've already learned. Let's get started. So as we're starting this bit here, we want to take this function right in polynomial form. Then I'll do it the same way I've done in the last two lessons where I give you the way to do it, and then we'll tie it back into this equation here. So when we start this, okay, I'm going to say f of x equals, and I'm going to just split it up here, okay? So just expand everything, 2x plus 3. Okay, now I'm going to start distributing here. And the reason I'm doing this is because I'm going to write it in polynomial form, then I'm going to take that derivative just using the power rule on every term. Alright, so it looks like I get 4x squared plus 12x plus 9. And I'm still multiplying that by 2x plus 3. Okay. And then if I multiply all that out, I'm going to get 8x cubed plus 12x squared plus 24x squared plus 36x plus 18x plus 27. Okay, and before I take a derivative, I'm just going to combine all these like terms. So 8x cubed plus 36x squared plus 54x plus 27. Now I'm going to take that derivative, okay? So when I do this, I'm going to say, okay, f prime of x equals 8 times 3, that's 24x squared. 36 times 2 is so plus 72x plus 54. And then the derivative of a constant is 0. And what I notice here is that I can actually, I can simplify this, okay? So if I bring this over here, I can simplify this, and I can divide 6 from each of those. So f prime of x is going to be 6 times 4x squared plus 12x plus 9. And then 4x squared plus 12x plus 9, that's 2x plus 3. And so really I'm just getting that from over here because that's how I multiplied those two together. So I'm going to get 6 times 2x plus 3 squared. And that is going to be my final derivative. So that's going to be f prime of x, and I just went through the extra effort of simplifying a lot of it. Okay, so as I said, there's a lot of talk about Leibniz and Sir Isaac Newton and what they did for calculus. But Leibniz was most likely the first one to actually use the chain rule. And here is the chain rule. So if we have a function that we're going to take the derivative of, and we can write it as the composition of two functions, so f of g of x or g of f of x, or any sort of thing where you can put one function inside of another, then h prime of x is the derivative of the outer function with the inner function times the derivative of the inner function. And that's it. So the way I said it is the way I always say it in my head. So the derivative of the outer times the inner, the derivative of the outer with the inner times the derivative of the inner function. And now we're going to go back to that function that we had above, and we're going to take that derivative. Okay, so go straight into it, f prime of x. So what I'm going to do here is I'm going to write out the outer part. What I would do in the past is I would say like, okay, let u be the inner function, then we would go like du and stuff. No, I'm just going to write out, so the outer part is going to be something cubed, and the inner part is going to be 2x plus 3. And we're really just getting it from that parentheses right there. Okay, so when I do this derivative, I'm going to take the derivative of the outer part, so 3, and then I'm going to hold on to the inner part, so 2x plus 3. 2. So remember, when you do that derivative, you're taking that derivative, you subtract 1 right there. So we brought the 3 down, now we need to subtract 1. So to the second power, Now we need to take the derivative of the inner part. So 2x plus 3, that derivative is times 2. All right, and if we just simplify this, 3 times 2, we're going to get 6, 2x plus 3 to the second power. And that's going to give us that full equation that we need. And it matches exactly what we had above. Notice above that took a lot of steps. So this is supposed to save us from doing all those steps. So now we're going to do a problem where we just need to find the slope of the normal line. So not the equation, just the slope. And we've got this equation, sine squared of theta when theta equals 3 pi over 4. Okay. When you take the sine squared of theta, just remember that just another way to write this is sine of theta squared. So now it becomes really obvious what's the inner function, what's the outer function. So let's take the derivative of f. So f prime of theta. So you're going to bring that 2 down, in front, hold on to the sine of theta, then take the derivative of that inner part. So what's the derivative of sine? That is going to be times cosine theta. And that's it. That's the equation. So now we want to find this f prime of 3 pi over 4. Okay, so 2 sine 3 pi over 4 times cosine 3 pi over 4. All right, so I'm going to get 2 times, well, sine of 3 pi over 4, that's square root of 2 over 2. And then cosine of 3 pi over 4 is negative square root of 2 over 2. All right, so these 2's divide out. And then I'm going to get a negative because they're both, one's positive, one's negative. Okay. And then square root of 2 times square root of 2 is positive 2. And I still have a 2 in my denominator. So negative 2 over 2, which comes out to be negative 1. But that's the equation of the tangent line, or that's the slope of the tangent line. So what we want is the slope of the normal line. And what that's going to give us is the negative reciprocal of 1, which is going to be positive 1. And that right there is going to conclude this video of this lesson on the chain rule. So the chain rule is going to get added into the product and the quotient rule that you just learned about. And we're going to now take a lot of practice going into how to actually use this in different scenarios. And it can actually be quite fun once you get the hang of it. So really focus on these problems, do them multiple times until you actually get the hang of it, and then go and attempt that homework and feel how smooth it is, right? Because you're going to use this many times, many times as you move forward in calculus. Of course, if you do need any help, make sure you guys do reach out to me. I'm Mr. Hernandez, and this is Mr. Hernandez Teaches.